Hey, awesome fourth graders. I hope you guys are having a great day. Today we're going to do something really, really fun, and we are going to look at this mystery science, and we're going to be using our knowledge of potential and kinetic energy in order to solve this question. Why is the first hill of the roller coaster always the highest? And if you think about that, if you're a roller coaster fan like me, you know that beginning part, you're kind of going up, 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 up. And it's always the highest hill. Why do we think the first hill is always the highest when we're talking about roller coasters? All right, we're going to listen to Doug and kind of explore with him online today to answer that question. So here we go.
Hi, it's Doug. Check out this roller coaster ride for a second. This guy's having a lot of fun. Now, one of the things that makes roller coasters so fun are all these ups and downs. When roller coaster designers create rides, they have to figure out how high to make the hills. So let's look at a few roller coaster designs to see how high the hills are. This is the layout of a roller coaster called the Intimidator. The cars start out in this building and they go up this big hill. They roll down, they swing to the right, turn back around, then they make their way up another hill, and so on. The cars, you can see, they go through a bunch more twists and turns on this ride. There's a few low hills, which you can see pointed out here. Out of all the hills in the ride, though, the very first hill is definitely the highest. All right, let's look at another roller coaster layout. This one's called the Behemoth. Its cars start in this building. They immediately swing to the left, climb up this giant hill, roll downhill really fast, and then go up another pretty tall hill, and so on. Now you see there are lots of hills in this ride. If I point them out, whoa, there's a lot. Most of them are pretty high too. But the highest of them all was this first hill that the roller coaster goes up. So in both of the layouts we looked at, the first hill was the highest. That's not a coincidence. You could look at 1,000 more roller coaster designs and their highest point will always be their first hill. Why do you think that is? Why is the first hill in a roller coaster always the highest?
All right, so I want you to think about that now. Why do you think that first one is the highest? Do you think it's just because they think it's going to be really cool? Probably not. There has to be a reason behind it. Why would the first hill be the highest? Okay, maybe you wrote down or keep it in the back of your mind. Why do you think? And we're going to keep exploring to figure it out.
Here at Mystery Science Labs, I'm setting up a model roller coaster to figure out why is the first hill always the highest? Now, right now, I've only built one hill, the first high hill. So I still need to make the second hill. I'm going to make this hill lower than the first one, just like a real roller coaster. All right, so let's see what happens when I drop a marble off the first hill. Ooh, makes it. Now, made it over that hill. That's not surprising. We knew that would happen, right? But what if the second hill is higher than the first hill? Like this. Now, what will happen when I let go? I'm going to give you 10 seconds to turn to your nearest classmate and predict what you think is going to happen when I let go of the marble.
All right, so what do we think will happen? Do you think it'll make it over, or do you think it will have a hard time?
Okay, let's see. Oh, it doesn't make it over, does it? So why does the marble make it over the lower hill, but not the higher hill?
Okay, so when that first hill was shorter, it was able to make it over, but not the second time. So we can think about why that is. Hopefully you're starting to think of some of those, the potential kinetic energy that we've talked about in the previous class. And think about energy. Why does it not have enough energy to go over the second one, but it has enough to go over that first short, smaller hill?
So why didn't the marble make it over the higher hill? Why does the first hill have to be the highest on a roller coaster? You all had a chance to discuss, and hopefully you're thinking about it in terms of energy. When the marble is dropped from a certain height, like say from here, there's a certain amount of energy you've stored in it by placing it up this high. The higher it's dropped from, the more energy you store in it. But that's all the energy it gets, no more. Watch. By the time the marble reaches the bottom of the first hill, it's got all the energy it was going to get from being dropped. You know, it's kind of like the marble has an energy meter, and at this point it's fully charged. In order to climb the second hill, the marble is going to use that energy, like this. See, it's going up, and it's losing energy. Since the second hill is taller than the first, the marble doesn't have enough energy to get to the top. You can see here that this marble was only able to get halfway up there. In fact, it can't roll up higher than the height of the first hill. You can actually see the same thing on the swings at the playground. If you pull back the swing like this and then you drop it, see, the swing isn't going to swing back any higher than where it started from. Let me show you that again. The swing is going to be dropped from here, the green line. When this boy's swing comes back, he's not going to go any higher than that line. Watch. Do you see that? Now, instead of a swing hanging from a beam like you see here, imagine we had a bowling ball. And imagine if you took your hands and you pulled back the bowling ball so that it was ready to swing. But now you put it against your forehead, like this kid is doing here. So you see that he's got a bowling ball on a string, pulled back and ready to swing. What's going to happen when this guy lets go of the bowling ball? Is it going to swing back and hit his face? Well, let's find out. You ready?
I have nothing to do with it. Okay, Brad, go ahead. Keep your head back.
Ooh, no, it didn't hit him. He looks a little worried, but he doesn't need to be worried. It actually can't hit him. The bowling ball can't swing higher than the height it was dropped from. So what does the motion of the roller coaster, a swing, and a bowling ball on a chain all have in common? They all get their energy from starting up high. They're getting their energy from height. And that energy isn't enough to take them any higher than where they started from. Now, I should note, the bowling ball or the swing could have gone higher. And so you do have to be careful with this, because if someone pushes on you rather than just lets you go, watch what happens. See, this dad is pushing on his son each time the swing comes back. And so this little guy is getting extra energy from his dad's pushes, making him actually go higher and higher with every swing. So to sum things up, a roller coaster gets all its energy from that first big hill. The energy stored from going up that big hill is what gets the roller coaster all the way to the end of the ride. If you made the second hill the biggest hill, the roller coaster wouldn't make it over. That's why the first hill in a roller coaster is always the highest. Today, you're going to get a chance to solve another fun problem using the idea of height energy. Watch the next video to find out what the activity is.
All right, guys, we're actually stopping there. I'm in this mystery, but I hope you all enjoyed looking at that and starting to think about some of those places where you can see height energy stored. And when we talk about height energy, hopefully you're thinking potential energy. When the dad was lifting the swing, when the kid was lifting the bowling ball, even the marble on the little roller coaster, fake roller coaster, they all had potential energy. So when you think about that roller coaster, that very first hill being the highest, it's so it can store all of that energy, and so that the ride will be able to go and be able to come back to where it's supposed to at the end and have the energy to get up all the other hills. All right, make sure that you answer your question in Google Classroom and have a great rest of your day. Bye.